The Transmitter.
Hello, this is Synaptic, our podcast here at The Transmitter that looks at the people, the research, and the challenges of the neuroscience field. This is episode 12 of our show. We've reached a dozen now. I host Synaptic. My name is Brady Huggett, and thanks for joining. All right, today let's go way, way back to 1587. That places us firmly in the Renaissance period. And let's go to Italy, and let's look at Julius Caesar Arancius. Now, I'm probably mispronouncing that name, but it's my best attempt. Anyway, in 1587, Arancius, who was an anatomist and a surgeon, published a book titled De Humano Foetu Liber. Now, I'm probably butchering that as well, but in English that translates to On the Human Fetus. And in this book, Arancius described for the first time a structure in the brain that he felt resembled a seahorse. And in Greek, the word for horse is hippos, and the word for a sea monster is campos. So he called this structure the hippocampus. Now, there were other names proposed for this by other people, and you can look those up if you're so inclined. But in the end, hippocampus is the term that stuck. Now, hundreds of years later, at the University of Arizona, a man named Bruce McNaughton was running his neuroscience lab. And in 1993, a college student named Loren Frank inquired about working with McNaughton during the summer break. McNaughton had a postdoc compiling a database of the various cell types in each subregion of the hippocampus, including the relative frequencies of each cell type. So it was there that Loren Frank was introduced to the hippocampus, a structure I had never heard of, as he says in this podcast. And it was during that summer that Loren says he figured out exactly what I wanted to do regarding his career. So that is our guest today, Loren Frank. We talked about his fascination with the hippocampus on this podcast. And we also talked about his time at MIT, where he was failing a project so miserably that he thought he might wash out of neuroscience altogether. And of course, we talked about relay events and how memories are formed. All of that and more coming up in the next hour. So I interviewed Loren on February 17th on a Saturday at his home in San Anselmo, north of San Francisco. It was an overcast day with a light rain coming down when I arrived. His house is up this winding road with a wonderful view of the surrounding hills. There's lots of greenery. It seemed almost rural, to be honest, and Loren said that they feel very lucky to live in a place so bucolic while still allowing him access to his job in a city. We sat in a lower floor in his house with his family upstairs, and that included the dog. I put mics on a table between us, and we got down to business. So Loren is really easy to talk to, and he's sort of honest and self-deprecating in a way that I found actually very funny. Maybe you will too, I don't know. Anyway, that should be enough to get us going. Let's start here, where Loren is talking about how he gets from his home to the University of California at San Francisco, where his lab is. And the commute includes riding his bike and also taking a ferry. So here's your episode of Synaptic with Loren Frank, starting right now. And so is there a Wi-Fi signal on the ferry?
Fortunately, no, but the tethering to my phone works almost all the way across the bay. So I pretty much have consistent Wi-Fi access the whole time, which is helpful. And sometimes when I don't, it's even better because then I can't do anything other than like longer timescale work stuff. So
what does that mean?
Oh, like working on papers or writing letters or grants or whatever
Something
else
that is not
that
tied to
doesn't
the
actually
internet.
require immediate online access.
Are you sort of like unplugged in that moment?
For that moment, I'm unplugged. It's a short moment, though, right? Most of the time, I'm plugged. Sadly.
We're gonna talk about that because
okay.
There's a couple of things in your research that, well, anyway, I wanted
to
say.
know about the offline replay and what that might be good for, and whether these periods of offline are actually really important.
Yes,
potentially,
and also the way the media has perceived that. But
yes, Yeah, that was it. I learned a lot about media interactions from the way that spiraled in various directions.
Okay. I'm going to get to that. Okay. Because I was fascinated by it myself. But let's go back to the beginning. So we're in San Anselmo, as I said, and it's an incredible view. Like it's foggy today, but you can see these rolling hills. It's gorgeous up here.
It is a truly beautiful place, and this is a place where, for better or worse, they set aside a large fraction of Marin County as conservation land. So the hiking, mountain biking here is quite extraordinary. It also means, of course, that property values are also painful, etc.
Sure, yeah. Well, that would go hand in hand. But so from here, can you go out and are there paths that you can pick up and hike around in this area?
Yeah, I mean, we can hike up to our local hill. We can drive across the valley and then hike for as long as we like along the ridges on the other side of the valley. And then other things, mountain bike trails and so on, are easy to get to.
How often do you do that? Do you spend your weekends?
So I almost every Saturday, except today, I go out with my boys and we do a hike somewhere. And then some Sundays I go mountain biking with a friend of mine. Not every Sunday, sort of depends on the weather.
Like mountain biking, like BMX downhill?
Yeah, I mean, cross country, yeah. I'm old enough that I try not to do large jumps and things anymore so I don't hurt myself.
Right.
But real mountain biking trails.
So it's like the age wisdom.
Yeah, something like that. Yeah. And I don't like hurting myself.
Well, who does? You have 2 kids?
2 kids, 2 boys, Aiden and Nathaniel, 18 and 13.
So Aiden's 18.
Yeah.
Yeah, he's quite tall.
Yeah.
Yeah. So, but you're not from this area. I know that. Yeah. And I think you were, I don't know where you're born, actually.
I was born in Albuquerque, New Mexico.
Uh-huh.
So I spent the first 17 years of my life there and then kind of wandered up around the country to finally end up here in the Bay Area.
You're born there. Does your family have a long lineage there, or how did...
No. So, slightly amusing story. We'll see if this is too long. But my father had worked, he was a psychiatrist at UC Boulder and sort of a campus shrink, as he described himself. Uh-huh. He ended up moving to the University of New Mexico as a psychiatrist there. And my mother was coming through, I believe she had recently come back from Moscow as a tour guide for an American exhibit in Moscow for the Rand Corporation. This was in the height of the Cold War. Uh-huh. And she came through Albuquerque and met my father at a cocktail party. I don't quite understand how exactly this happened. And that clicked. So they spent a total of 26 days together after that meeting over the course of the next 6 months and were married. And that was...
so 6 months after they met, they were married.
They were married. And,
after spending 26 days.
And then she moved to Albuquerque, New Mexico, where she had no previous plans of being. And so that was where they ended up.
But your father, where's he from originally?
So my father was originally New York, actually. So he grew up in New York City, spent his summers in New Hampshire. My mother was a Holocaust survivor who was in hiding during the war in Holland and came over with her family with sort of nothing, started in St. Louis. She actually was sort of an au pair or a live-in au pair for a Hollywood director who sponsored their family. So she went to Beverly Hills shortly after coming here after the war and spent some time there helping with his kids.
Your mother was a Holocaust survivor?
Yes.
So she's still alive?
Yeah, she's 88.
Oh,
she just turned 88.
Wow.
Yes, so kind of remarkable. She lives with us, so she's upstairs, kind of behind me. She's an amazing person. Yeah,
I mean, have you obviously talked through that history?
Oh yeah, no, we know it. My children know it, and she actually still does talks to people around here about the Holocaust, about the lessons she's learned from it, things like that.
You know, we're already off topic, but I don't care. So some poll just came out. A shocking number of people like 30 and under think that maybe the Holocaust is not real. Is she aware of that?
Yes. Yeah. No. And I mean, this is part of her she goes to schools actually and gives talks to the kids there sometimes. I think the reality denial that we're seeing in all aspects of our society, right, has been growing tremendously. But it is clear that things that are out of mind now and there's not a lot of history left apparently in the curricula to make these things clear. So yeah, it's actually totally terrifying.
It just feels like if they made everybody go to Auschwitz and tour it,
yes,
that kind of thought would go away.
I agree.
It's shocking. Is your dad Jewish?
No,
okay.
Not at all. Non-religious growing up. So I was raised with a little bit of Judaism on the side, but not seriously.
Yeah. So he's in New York.
Yep.
He gets a job eventually at Boulder.
Yes.
As a campus psychiatrist.
So
what does
he was
that mean?
a campus psychiatrist. So he basically saw the students who were having troubles. And as you know, that's a period in life where psychotic breaks and other things are starting to happen. Yeah. So he was dealing with people, onset of psychosis, depression, and other things among the student population.
He gets a job in New Mexico.
Yes.
Your mother meets him there at a cocktail party.
Yep.
But she's in New Mexico for some reason.
Yeah, she's flying through. I don't remember why she was flying through, but she had to spend a night there. Huh. And that was basically it.
And someone said, come to this party.
Yeah.
She meets this man.
Yes.
She's like, that guy's kind of interesting.
Yes.
Maybe I can see him again.
Yes.
They switch numbers or something.
Yes, exactly. And one of those extraordinarily random stories.
Yeah, but then it works. Is your father still alive?
No, he passed away 6-7 years ago now. He was 13 years older than she was.
Yeah.
So he passed away at 92. He had also smoked for 27 years in the middle of his life. So the fact that he made it to 92
shocking.
Was pretty. He was a tough individual himself.
Yeah. Okay, so obviously the marriage works.
Yeah, it worked. Not always as smoothly as one might imagine, but it definitely worked.
Yeah, I mean, meeting people at cocktail parties is still a way that does it, I guess. Yeah.
Occasionally.
Okay, so you're growing up beneath a psychiatrist's father and a mother. Did she work when you were growing up?
Yeah, so she was actually working on her PhD when I was young in infant growth and development.
Wow.
She got that, I think she was doing that around the time I was 5. And then she was teaching at the University of New Mexico, graduate courses, and then actually eventually went and worked at the medical school there doing sort of basically trying to teach doctors how to actually interact with patients as human beings.
Better bedside manner.
Yeah,
that kind of
and
thing.
she also did some sort of family therapy, marriage counseling on the side. So it was a very psychologically oriented household, for better or worse.
Yeah.
And my efforts to avoid doing anything like that obviously failed utterly. But I did try for the first many years of my life not to do anything in that realm.
Okay, that was going to be my question, is sort of how did you get into this line of work? But it's clear that there were mentors above you, or at least models that you could look at.
Yeah.
But you didn't want it.
No, I mean, I thought it was too fuzzy for me, to be honest. It was important and interesting to know how people worked, but it was always a just so story of, oh, this person did this for this reason. And of course, those just so stories are incredibly important as we navigate our own lives and try and understand people's reactions and interact with them. But I didn't find them deeply personally satisfying. And I'd always known I wanted to be a scientist from like age 5.
You did.
But the things that were most exciting to me were physics. So like astrophysics, cosmology, particle physics, things like what is the fundamental nature of reality.
So at 5, you're pondering.
I didn't know this. At 5, I wanted to be an astrophysicist, I said. I don't think I had a deep conceptual grasp of what that meant. So let's not overstate my intellect there.
Well, but probably because the stars and the moon, those things are fascinating to children. Yes. It was that kind of thing.
It was that kind of thing, and just how does the world... I loved understanding how the world works. This is the thing. The thing that drives me professionally is just understanding how the world works.
Right. So now it's the brain, but then it was like, what are planets? How are things aligned? All that kind of stuff.
Exactly. Where did this all come from? And I think, this was... like late 70s when I was 5, 1977, yeah. And we actually knew a lot less then than we did now. So there were still things to figure out.
Mysteries.
Yeah.
Well, there's still mysteries today.
There's still mysteries. I think the granularity. So some of them are very big and very far away. The mysteries, I think, I'll say the thing that caused me not to do physics was a combination of a realization that I wasn't smart enough to be a Feynman or an Einstein. And that was clear to me when I got to sort of the early stages of college. And also sort of the recognition that those projects tended to be huge things, which were difficult for individuals to make sort of really substantial contributions to, the things that I might do.
Okay. Okay.
Sorry, there's a lot between that,
obviously. Right, okay. But so that meaning that to make some huge breakthrough in that field, you would need a group of 200 people.
Yeah, or 5,000 if you're working at an accelerator. Together. Or if you look at what most physicists were working on, it was things like, what are the properties of superfluid helium-3, or what does this do in this context or that? And it didn't feel like I would have the opportunity to do something that could be really fundamental. I mean, I didn't feel like I had the mental talent to do that in a field like physics. I didn't think I was likely to discover the theory of everything.
All right, we're going to come back to that. So anyway, you're growing up and you're looking at the stars and the moon, maybe with your parents, I don't know, but you're interested in this and you think that's what you want to do. And does that hold all the way through high school?
All the way through high school, yeah. So I was always particularly interested in physics and related things. I read a lot of books on, popular books on physics and so on. I ended up going to a small liberal arts college because I wanted that kind of experience, but I chose one that had a good physics department because I thought that was where I wanted to go. And then all the way through basically most of my first year of college, I thought, okay, I really want to do physics.
So that's Carleton College.
That was Carleton College.
All right, so you're finishing high school. I'm assuming you did well in high school.
Yeah.
Yeah. And did you consider things like, I don't know, Harvard, Stanford?
Yeah, I did. I didn't So I think a couple of things in retrospect. I didn't really know, coming from Albuquerque, New Mexico, where I stood in terms of abilities related to these things. Yeah. I wanted someplace small where I could really get to know my professors. And I felt like that was really unlikely to happen. I didn't want to, at larger places, I didn't want to be in a lot of graduate student taught classes. And I just wanted to be in some place sort of friendly. And I had visited a bunch of schools, and I didn't get that sense from others. Like East Coast places just didn't click with me. Whereas this sort of nice Midwestern place was a really good fit. In retrospect, I would have given myself different advice, although I'm very happy with how it all turned out. So going to Carleton actually opened some random doors that led me to doing what I'm doing now. Yeah. But statistically speaking, that's perhaps was, maybe, I'm not sure it was exactly the best path for me personally.
I have to say, I had not heard of Carleton College. What's the enrollment like?
Oh, it's 2,400.
Yeah, small. Okay,
it's small.
Okay, so how did you even? I guess because of the physics department.
Yeah, it was one of the top-rated liberal arts colleges, right? Sort of along with Williams and Amherst. It's just not as well known, and it had a quite good physics department. And I visited there. I visited Williams. I visited Amherst, and I really liked the feel at Carleton.
So I don't know a lot about it, but it's a town called Northfield, I think, right? Which is an old mill town set along a river. I mean, I could see how that would be enticing.
Yep. Yeah, and it was more the friendliness of the people. That when I visited there, I just felt like people were nice to each other.
We should say it's in Minnesota.
Yeah, it's in Minnesota, so there you are.
So so these are a bunch of Minnesotans.
Yeah, and I mean it's somewhat more diverse than that, but it felt like a very nice place with high quality academics and the ability for me to learn what I wanted to learn.
Accessible teachers.
Yes.
Good physics department.
You got it.
You're all in. Okay, so you enroll there still thinking, I'm going to be a physicist.
You got it.
What happens?
So I took classical mechanics my first year, and I did fine in it. I hadn't really learned things had come easily up to that point, so I hadn't learned to work super hard, so I ended up with an A-, not an A, but that's fine. But I realized that I could do the math and solve the differential equations, but I just didn't care that much. And then I took atomic and nuclear physics my first term of my sophomore year, and it was kind of the same thing. Like, this is all fine, but I just didn't care that much. And I'd sort of realized that the things that I'd gotten interested in physics by that time were things related to quantum mechanics, and this idea that the world is different when you look at it than when you don't. So the sort of concept that, light, for example, is best described as a wave if you're not observing it. But as soon as you put a detector in the way, it looks like a particle. Yeah. And so this idea that there's kind of a fundamentally different reality when you're looking at it compared to when you're not, I thought was kind of amazing. And also elevated the observer or the observation process to a really interesting place in the universe.
Yeah, it's almost like when you think about it that way, things are more mysterious than you knew, and it's worth exploring. Yeah. Like that.
Yep.
Okay.
Absolutely. So that was really exciting to me. And at the same time, I realized that was not what most physics was about. So this was, coming back to what I said earlier, I felt like I was unlikely to be studying that. That was more of a lunchtime conversation than a career. And so that sort of made me realize that, it was actually when I sort of came to the point that it was like, oh, wait, maybe it's the observer that I actually want to understand, not the quantum mechanical parts of it.
But that's different from I'm never going to be a genius at this.
Well, it was all of the above. So both it was I didn't think I could study exactly what was most exciting to me in physics. And the other stuff that was most exciting, that was also exciting, was not stuff that I was likely to really move the needle on.
And were you meeting kids at Carleton who you thought, well, that person actually is going to move the needle on?
No.
Well, how did you know that you weren't going to move the needle?
I think this was just a sense I had from, reading biographies of Feynman and folks like that, and what they were like at kind of my age, and recognizing, okay, that's not really me. I'm smart. Right. And I'm good at thinking about things. But what I turn out to be good at, and what I think I realize I was good at, is more of a synthesis kind of thing rather than the sort of extraordinary depth of comprehension in mathematics and physics realms. Okay.
So do you change your curriculum?
Yeah. So then I became a psychology major.
Right.
Which was a shock to me, honestly. Yeah. And
was it a shock to your father?
They were always very supportive of whatever I wanted to do. I think they might have felt sort of quietly smug, but they never told me. So it's hard for me to tell. I think they thought that was interesting and perfectly fine, and and so on. And I was pushed towards, or I was interested in kind of cognitive psychology, again, kind of understanding the properties of the observer. And that was really a valuable experience, but that was also actually, I found, pretty dissatisfying after a year or two, because while you had it lacked the same problem I had with the psychology growing up, is it lacked what felt to me like a sort of the rigor of being able to make mechanistic statements.
Well, first off, I'm going to write down the term quietly smug because I love it. So you mean that the psychology part would be like, we think people act like this for these reasons without any like math applied to it, without any...
Exactly. And where there was math, it was very sort of hand-wavy math, and it was not predictive in any way. It was all sort of postdictive. Right. And I think that's it, is this idea of like what science should be, what we should be striving for is something where we can say, hey, this is what we think is going to happen.
Yeah. Rather
than, oh, this is what happened, let me make up a story about it.
Yeah. Okay. But so this is how you become a sort of unique researcher. I don't mean you, but I mean like everyone finds their own unique thing. Right. Yours is like, I've got this kind of physics background. Now I'm going to apply that to psychology. Yeah. And it gives you probably unique insights.
Yeah. And I've also always been like a programmer. Yeah. And so the programming and the math and the kind of this idea of maybe we can write things down mathematically combined with this idea of, hey, these really interesting questions about how does this brain thing work? Yeah. That turned out to be the sweet spot for me.
Okay. So then by your senior year, you're a psychology major, and what is your plan?
So there are a couple of things that happened in between that were very random and very lucky for me. The summer after my freshman year, I had applied to some summer internships, and I got one at the Minnesota Supercomputer Institute. And so I went and I worked in Minneapolis, and I worked at the Supercomputer Institute, and I learned a lot about graphics and programming and things like that. And amusingly enough, the project we were working on was perhaps one of the first efforts to train a neural network to predict protein structure. Oh, wow. And I had no idea that this was interesting at the time. And at the time, I didn't even think it was interesting, but we were supposed to help with the visualization of protein structures and things like that. So I learned to do a little bit of that. And that led me into a second summer job the next summer, this time kind of across the street at a place called the Army High Performance Research Computing Center, where I worked with a graduate student. She was great, and she was working on a single neuron model. So she was using these really high-end machines back in the day to try and simulate a single neuron. And so I also helped her with the visualization. So this was the beginning of a completely random exposure to neuroscience. Yeah. I sort of stayed affiliated with them, and I actually did, that summer I also did, I think, a 4-week summer course in neuroscience at the Itasca Field Station of the University of Minnesota, which is at the headwaters of the Mississippi on a lake, where I worked with people doing neuroscience experiments. So we were working on turtle cerebellum and frog and things like that. So pretty random. I didn't know I was interested in this, but it turned out the combination of using these fun electronics tools and poking neurons and measuring things that I was pretty good at, and this is cool. I enjoy this.
I can see how this all lines up. What I'm struck by is, were you looking for these? How were you coming across these?
Yeah, I was looking for things. So I knew that I want, I guess, so this is why it was random. I knew at first that it would be interesting to do, that I found computing and programming interesting. And so just the opportunity to work at a high-performance computing center was great.
But you sought that out.
I sought that out. Right. Yeah, and I think that was also a lot of it. So luck, yes, but I was always looking for opportunities to do something that seemed interesting.
Amazing. Okay.
And the person who supervised me, a guy named George Wilcox, lovely guy at the University of Minnesota, he liked working or liked having me around, so he helped me get the job the next summer. And then after that, this was actually one of the real benefits of Carleton. The summer after my junior year, I had applied to 10 labs around the country based on advice from one of my psychology professors to work again on a project. And the one of the two that was willing to hire me was at the University of Arizona. And they were interested in the hippocampus, a structure I had never heard of. But they wanted someone who could build models, computational models of this structure based on sort of a new database they were creating of all of the different kinds of cells. And they were willing to hire me. So I went to Tucson for the summer after my junior year, worked on this new part of the brain that I didn't know about. And that was it.
That's it.
That was where I figured out exactly what I wanted to do.
Okay. All right. So entering your senior year, you now know you want to look at the hippocampus.
I know I want to look at the hippocampus. I went back there for, instead of spending my 4th winter in Minnesota, I instead spent that 4th winter in Tucson.
Yeah.
Because it's a lot nicer place to spend a winter. And so I did my senior thesis project working on this computational model of part of the hippocampus back then.
Okay. So I know, or I don't know, I think I know that when you finished, well, first off, you won like the Donald B.
So this was a prize for it was a co-winner of the prize for the best undergraduate thesis in psychology in the state of Minnesota.
Right. I mean, you're kind of making dismissive hand motions, but did that give you a sense that you're on the right track?
Yeah, it was interesting. Again, it's still Minnesota, right? And I don't mean to diminish that. It's
not a national award.
It's not a national award. It's psychology in a state, right? So I had a hard time knowing exactly what that meant in terms of my capacity. So I knew that people liked me and so on and so forth.
You've been invited back. The guy you worked with that one summer said come back. So you
yes,
knew that
exactly.
you were contributing.
So yes, I had this general sense. And I think this actually might be surprising to people because I definitely came across as arrogant back then. So I think I was both outwardly somewhat arrogant and inwardly kind of unsure because, again, of this feeling that I was no Feynman or Einstein. How good could I be at this? So it's sort of a weird mixture.
How do you know that people found you arrogant?
Well, the first time was when I got the write-up from my 7th grade shop teacher that I was a bit arrogant. So, to be honest, I was arrogant because I had a shop at home. So my dad had a lot of woodworking tools and he taught me to use them. And I was kind of annoyed that I had to use only hand tools and couldn't use any of the electrical tools that I had been using. And apparently I was kind of obnoxious about that.
Got it. Okay.
Yeah, I mean, I think I was clearly a little bit cocky about some stuff. And I will say when I ended up in graduate school, things had always come fairly easily to me. And that was something that killed me for a while in graduate school because I was now trying to do something actually really, really hard.
Right. You said earlier that you'd gone from high school to Carleton, and I get the sense that maybe in high school you just kind of were blowing tests out of the water and you didn't maybe work that hard.
Yeah, I didn't. I worked. It's a little complicated. I went to a really good high school.
Yeah.
And my friends, like my junior and senior year, are like, they're really smart. And I was really fortunate to be with them. But again, I didn't kind of know how smart they were.
Yeah.
Right. I like, okay, so we're doing well here, but what does that mean? I didn't know what that meant in a global scheme. And so, one of my friends went to Harvard, started his PhD there, ended up going to a hedge fund. He's now a multi-millionaire who lives off of Central Park.
Yeah.
Right. So I now know that those people were, really very talented folks. And I just kind of didn't know that at the time.
Yeah.
So I was doing well. I worked sort of hard, but I don't think I understood what it meant to like really be systematic and apply myself to things. And that was something I had to learn the hard way in graduate school.
Okay. So you finished Carleton, and I think you're planning on going to the University of Arizona or something,
Correct.
right? But something...
So the story here is I was at the University of Arizona, and the computational project was really... useful. I learned a great deal from doing it, but I also learned that I had to make a lot of stuff up. So, ideally, if you're building a model of something, you want to make up as few things as possible so that you're not searching for ways to make it work, sort of parameter space searching, in such a way that you think what you find, you want to find something that is going to be robust and going to be generally true and not the result of tweaking this and tweaking that to make it work exactly.
Right, okay.
And I was tweaking things like mad, and it was very unsatisfying to me. So I kind of figured, oh, wow, I really don't want to do that. But at the same time, this laboratory, so this was specifically Bruce McNaughton and Carol Barnes, they ran a lab together at that point at the University of Arizona, and an incredible postdoc named Matthew Wilson had built this system for recording large numbers of neurons from the rat hippocampus. This was the first system of its kind anywhere in the world. They had, many, many more electrodes and the ability to start looking at populations of neurons, which was basically unheard of up to that time. And I got to help with some of those experiments. And when I first heard those neurons, because you often run their activity through a speaker so you can hear what they're doing, it's like, oh my gosh. This is a structure that's involved in cognition. It's critical for memory, and I can study it and I can listen to it. And so that was kind of the thing that said, okay, this is what I want to do. That lab was the only one in the world that had access to that technology at that point. Matt Wilson was going to go off, but he was planning to work at a private neuroscience institute with no graduate students in La Jolla. And so I applied to graduate school there, was accepted in like February.
At Arizona.
Yeah. Quietly smug again. Like, oh, good. I know what I'm doing. I know where I'm going. And then I think it was sometime in March, I was back at Carleton, I believe. And I got an email from Matt saying, I changed my mind. I'm going to go to either MIT or the University of Pittsburgh as a faculty member. Do you want to come with me?
Whichever one.
Whichever one.
Yeah.
And I hadn't applied to either one. So that was kind of freaky. So,
well, how does that work? So he's going there to set up a lab and you'd be his grad student.
Yeah.
So you still have to apply through the school and then, okay.
But I hadn't applied.
Yeah.
So I didn't know how any of that was going to work. I have very strong memories of this whole process, as you might imagine. So I thought, but I haven't applied. What's going to happen? So I ended up calling up the director of admissions at both places, and it was a starkly different sort of response at the two places, to be honest. At the University of Pittsburgh, the person I talked with was a little hesitant at first, and I said, look, here are my GRE scores. I had an NSF graduate fellowship at that point, which I applied for. Here are my grades, and here's what I've done. And he said, okay, don't worry about it. We'll let you in. I did the same thing at MIT, slightly different order. I think, here's my grades, here's my GREs, I've done this, my grades, I have this NSF, here are my GRE scores. And then I remember very strongly the response from the director of admissions this time, which was, oh, so you can speak English too. So after this experience of talking to the people at Pittsburgh and MIT, I said, oh, Matt, please go to Pittsburgh. Because
you'll get in there.
I'll get in there, and they seem a lot nicer.
Yeah.
And that was still very important to me at the time. Matt doesn't decide till June. I've ended up turning down Arizona on the deadline date, April 15th, not knowing if I'm going to go to grad school at all next year. And so I apply. Matt decides, I think it was in June. I apply. He decides to go to MIT. I apply there. Fortunately, they let me in.
Without Matt, though, I mean, the neuroscience program still exists at Arizona. Why didn't you consider just staying there?
I did. Yeah. So it was that Matt, I felt like, was a real sort of originator of this technology. And he was also the one who had written the neural simulation framework called Genesis that I was using to do my work for the computational models. Yeah. And so I felt like that combination in a mentor was really valuable. In retrospect, I didn't ask all the right questions either. Now, I mean, again, it worked out really well, and being at MIT gave me access to things that I wouldn't have had at the University of Arizona, so that was good. But also, those years of my graduate school were the hardest, worst years of my life in many ways.
Oh, okay. Well, let's talk about that. I mean, I would assume that they would be, well, I wouldn't assume, but I would think they'd be hard, but why were they the worst? I'm going to ask one thing. Like, did you find Boston unfriendly? Did you find MIT unfriendly?
Yes and yes. And here I want to be careful to sort of not overstate my experience, but I'll try and give you the best sense of it I can from what happened. So I got to the lab. I actually got to MIT slightly before Matt did.
Yeah.
And so we spent the first year setting up the lab. Matt had hired some other people who were fantastic. We were building things. I was learning how to use my hands for fine motor stuff, which I hadn't really done before. That was hard for me.
Yeah.
And that first year I thought went pretty well. Then I was trying to do what turned out to be an extremely difficult project to record from the hippocampus, but also the part of the brain that gives it its main input and receives its main output, the entorhinal cortex. And Matt had not done that, and I had to figure it out on my own, and I wasn't sufficiently systematic. So I spent 3 years failing utterly to collect any meaningful data.
Meaning you're just tweaking things and seeing if it works.
I'm tweaking things, but I'm not doing it in a super careful, systematic way. And Matt was also, he was an early stage. He was also a fairly hands-off, sink or swim kind of guy at that point. And so I just kept failing, right? And I was miserable. I was working really hard. I was doing a bunch of other stuff, but I was not succeeding at my fundamental project, to the point that the program was, because I hadn't done a requirement to write up my research work by my third year or so, the program was very concerned about my progress and kind of whether I should stay in graduate school at all.
What did you think?
I was frustrated. The way I often phrase this is I didn't have the creativity to think about anything else I could do with my life. Like, I'd always wanted to be a scientist. And I hadn't failed spectacularly at anything ever before. And I was not willing to quit. So
did you have a sense of like, did you have a crisis of confidence yet you're like, I'm just not going to quit. That's not in me.
Yeah, I definitely had a crisis of confidence. I wasn't sure I was ever going to be successful. And as I told my girlfriend at the time, now my wife, I'm not sure I'll ever be happy. So I was
in life.
So, the things that this did, so that part of it, like I started grinding my teeth, so I don't have canines anymore because I ground them away at night from, the stress of it. Right. It was really, really hard.
Okay. So 3 years in, you're grinding your teeth. You're telling your girlfriend, who will eventually be your wife, I may never be happy. Somehow she sticks with you when you say that. But you don't know if you're ever going to really make it as a scientist. Like, how did you turn this? I mean, I know you did a postdoc after this at Harvard.
So a couple of things happened that were great. One, and I guess I want to be fair. Like, the lab had great resources. There were lots of really smart people here. Matt was always very kind to me, let me do things. So I had an environment where I could succeed.
I mean, MIT is a phenomenal place.
It is. Yeah. So I think there was a lot of stuff there that I need to acknowledge. And again, the failures of my own research were a combination of my own sloppiness and not understanding what I need to do, but also being kind of left alone to do my own thing.
Yeah.
Right. And that may have changed in various ways by now. Then one thing that I did in my second year is I was still, I've always been pathologically optimistic. So that's another trait I have. Mm-hmm. I will get this to work eventually. I was reached out to try and find people to jointly work with on the analysis of our data. Because this was sort of the early days of having large numbers of neurons. We didn't really understand how to work with those signals. And after various not terribly successful attempts, I ended up arranging a time for us to present what we were doing to a group at the Harvard Statistics Department, which happened to be in the context of a class, or after a class that Emory Brown, who's at Harvard and MIT now, was teaching. And that was a interesting meeting, didn't really go particularly far, but I then contacted Emory afterwards and say, hey, would you be willing to do an independent study with me where we could maybe think about ways where we could develop new techniques for understanding
Got it. Okay.
That was one of the best decisions I've ever made. So I ended up spending 3-ish hours a week or more going over to Emory's place in the North End, which happened to be where his office was because he was at Mass General Hospital. And he would teach me statistics, and we would brainstorm about ways to do things, and hopefully I taught him a little neuroscience. But that relationship and the analyses and papers that came out of that were really fundamental, I think, to keeping me in the game.
So this was, I think, 2000 to 2003, is that right?
Yeah. No. So this was 1995 that I started this.
Got it. Okay.
And so the first paper I was on was 1998, which was a first author paper by Emory Brown developing a new decoding method for understanding hippocampal activity. And that, I would say that happened because of this connection with Emory, and then that created a connection from Emory's to Matt's lab. And so Emory developed these techniques, and I kind of followed along.
Yeah. So, but when you finish your PhD, then you go work.
Then I went to work officially with Emory.
For 3 years.
Yeah, to do that. And also with Garrett Stanley, who was a faculty on the Harvard main campus in engineering, who was also incredibly generous to me. He basically had a room built in his lab so I could do the multi-electrode recording experiments that I wanted to do. I taught someone in his lab how to do them. Although in retrospect there also that I should have done a better job at as well. I think I didn't. I was too focused on my own sort of path and not focused enough on sort of making mentoring or making sure that things were really working for this other person. Because, I was still, I think I was still like worried about my own success fundamentally and not as focused on sort of the broader community I was in.
I know you had those 3 or 4 years there at MIT where you thought you might be leaving I don't know if you thought you were leaving, but you're having a rough time. So
I certainly thought that I was not going to succeed. Right, that the thing I'd always wanted to do in my life, I was going to be a failure.
Yeah, and never be happy.
Right. That was.
So then you do this like statistics and neuroscience postdoc kind of thing at Harvard and Mass Gen. And then I think you come right to UCSF and start a lab, right?
Yeah, that's right.
Were you an associate professor with that?
No, assistant professor. So it's early days. I, again, sort of slightly random happenstance. I got a email, I think, from someone I knew at MIT who is a faculty then he was a grad student at MIT, and he then was a faculty at that point at UCSF, and said, hey, we're doing a search now, and we think that having someone who does hippocampal stuff might be a good fit. Somebody mentioned that you might be good. And I'd been collaborating with Howard Eichenbaum at Boston University and my longtime friend Josh Burke, who was a postdoc then, helping them get stuff set up for this multi-electrode stuff. So Howard actually recommended me to the folks at UCSF, which was really generous of him. And then, that story ended up with me going out there, interviewing, getting eventually a job offer, and taking it.
Were you married by then?
We were married. Yeah, we were married. And this was actually another thing that did not work out the way that either me or my wife expected. So she had gone from an art history undergraduate degree at Wellesley to working at MIT, eventually actually in the Tonegawa lab. And then she was able from there to get a position as a graduate student at Boston University. And she was working on her project there. I had told her, look, I'm going to UCSF, but we'll stay here until you're done. And then we didn't. So I took the job and I put off the start date for a year, but that still wasn't enough for her to finish her data collection and basically do her PhD. So,
did she mind that?
Yeah, it was a stressful period in our relationship. I think, again, I know so much more about how to manage these things now.
Relationships, you mean?
Relationships and science, right? And like, how would we do this? And so we sort of decided that like the UCSF was just an incredibly good fit for me. I had no idea that a place like that existed at the time. And so that just felt like home in a way that I hadn't felt being in Boston at all. Yeah. And then again, that's my personality conjoint with what happens at UCSF. It's a really supportive, collaborative, friendly place, which is not too self-congratulatory.
Okay. So you come out and set up your lab eventually, right? So what is it? What were your plans when you set the lab up?
What I had tried to do in my graduate work was to understand what was going into the hippocampus and what was coming out of the hippocampus. Yeah. And in my postdoctoral work, I tried to do something similar where we first developed methods to try and understand how neurons change with learning. Yeah. And so here a little bit more background is helpful. So the hippocampus is a brain structure critical to forming memories for the events of daily life. So what's thought to happen is in the hippocampus and maybe between the hippocampus and other areas, there's huge changes in synapses, lots of plasticity that enables this sort of one-shot learning that is the learning of everyday experience that we have every day. So the implication there is that the plasticity and the way that neurons change is really fundamental to what the hippocampus does. And the hippocampus is also critical then for retrieving these memories, at least for a while after they've been stored. And that presumably is some sort of process where the hippocampus helps engage the rest of the brain.
Right. Okay.
At the time, I could not have phrased any of that in a coherent way. What I knew was the hippocampus should be plastic and should evolve quickly with experience, and we didn't really know how. So working with Emory, we developed techniques for really trying to track how neural responses change on a moment-by-moment basis. And then working in Garrett's lab, again, with his generosity, I was able to do some recording experiments from the hippocampus and from other areas, sort of cortical areas that might feed in or receive output, that where I exposed animals to new places to try and understand how these responses evolved in a new time. Yeah. And specifically, there had been this idea that the hippocampus was a very fast-changing area and the cortex was a slower-changing area. And I wanted to test that hypothesis as a postdoctoral fellow.
Right.
Okay. So I did all of that. The test of that hypothesis as a postdoctoral fellow didn't work out. Again, this was partially my fault because I wasn't sufficiently targeted and I didn't think about analyzing my data in quite the right way. But I learned a lot about how the hippocampus changed, and that sort of set me up to ask, okay, what do I need to do next to actually do this? And so what I thought about doing next was the same sort of idea of, okay, we really want to trace through at every stage of this circuit, how are signals being transformed? So what's special about this hippocampal circuit that would let it form new memories or do things like that? Mm-hmm. So that was then, okay, we need to record throughout these areas while animals are learning new things. We need to do that across different environments so that we can understand how that learning might change from one place to the other. But it was still a relatively unformed set of ideas. It wasn't a crisp hypothesis about exactly how the system worked. It was, we need to go look.
Right. So, but in my understanding, when you do go look, and this is in rats, right?
Yep.
what you find is the learning is happening when the animal is not actively doing it. Right?
Yeah. Okay. So this is
replay events. This is
replay events. Yeah. And I guess here, what we had not been focused on replay at all early on in my career.
But I can see how you end up getting there.
Yes. Yeah, exactly. And so what we were looking for, like what one of our first papers was let's look at what's different between novel and familiar places so that we can understand what might be learning. And there we identified these sort of events that seemed to be happening kind of all the time, where lots of cells were firing together really, really strongly. And that was that first hint that maybe there's this stuff, but a lot of that happens sort of offline. A lot of that happens not while the animal's running through a place, but it happens while the animal's still at, elsewhere in the place. And that was sort of this first hint. And then in parallel, we started looking at also these replay events more directly, in particular because Tom Davidson, who at that point was a graduate student in Matt Wilson's lab, came and gave a talk in our lab and presented some really exciting preliminary results on these events. And so we asked him, hey, is it okay if we look at these in our data too? And he said, sure. And that exciting preliminary data led us to look at these sort of replay events. And because we've been looking at multiple environments, we were able to see, for example, that the animal could be replaying one environment while it was paused in another environment, which is something no one else had sort of done the experiment to do.
Yeah. I mean, so when I saw that, I was totally fascinated by that, because you can realize, or at least I realized, that I do that myself. Like, you'll be sitting in a chair doing something kind of not particularly with your mind fully engaged, and your mind will take you someplace else really quickly and drop back.
Yes.
And you're going, why does that happen? And it seemed like you had figured out why those things happen.
Yes, exactly. So I think there's the what versus the why. The what happens, I think we have now a good sense for that. We can see, fast forward 20 odd years, we know what the signatures of this kind of mental jumping are, and we can see them all the time in the hippocampus, or very frequently in the hippocampus in lots of different contexts. The why part is trickier, right? So the why part is, what exactly would this enable the system to do? And there we had some hypotheses, which were, okay, look, neurons firing closely together in time, that's a good way to induce plasticity. So maybe what this is something that's inducing plasticity either in the local network, that's allowing for the storage of the memory in the hippocampus, or perhaps driving plasticity downstream in the rest of the brain. And
to the cortex.
To cortex, right? And that's still the idea. And ironically, that still hasn't been fully tested. Right.
So this is the squishiness sort of that you're talking about before. We think this is why we haven't been able to prove it yet. But you were able to show these neurons firing in the same way in an animal's brain when it was at rest, as it had just fired when it had gone down a maze a certain way. Right? It was fascinating research. So it brought up all these questions in my mind. One of them is the difference between sleep and awake replays. Are they exactly the same? And then, if they aren't, do dreams play into that?
Yeah. So then this idea that the brain is replaying these things, what we also looked at in that paper, which you're alluding to, is what's the fidelity of this replay in different brain states? So in the awake state, you often get these really beautiful sequential events, which look very much like time-compressed versions of the real thing.
Yeah, very, very fast.
Turns out you get lots of other events that have other complicated structures, which are also, I think, really interesting, where the brain might just hover in another place or something and not be a beautiful sequence. But for this part, we were really focused on the sequences. It was known before then from work, particularly from Matt Wilson's lab, that you also see these sequences during sleep. And that was also where a lot of this started to be, give credit where credit is due. And what we did is then compare them, and surprisingly, the sleep sequences looked less ordered. They looked a little more free-form. So neurons that maybe shouldn't have been part of the sequence were part of the sequence, or maybe the order was a little disrupted. And so
that is so fascinating.
It's fun because you can imagine, well, look, if the brain can tweak a knob as to the sort of accuracy of a memory, you can think of this as kind of along an axis where the more accurate it is, the more specific it is to one experience, but the less it lets you generalize. And the more squishy it is, the more it might include related stuff, the more it might let you make connections between things that were not connected at the time. So that led us to this hypothesis that maybe this sleep stuff is actually important for something that you might more think of as insightful learning. And it may be, that hypothesis may have been out there. I can't now reconstruct the order of these things. But this idea of sleep or really offline periods as insightful stuff goes way back historically, like keculae and the structure of the benzene molecule and things like that. So sorry, that was clearly not our idea. But here, this might be an instantiation of that, where the brain regulates accuracy to change the way that to change the kinds of memory storage that are going on.
Yeah, I mean, you can see how, at least for me, I'll have a dream, I wake up in the morning, and they seem bizarre, they seem surreal, but when you begin to break them down, you'll realize that in your dream you had seen a burning house, and then you realize that while you were on a bus yesterday, you'd seen a house that had collapsed. I know that this was in rats, of course, but you begin to be able to apply it to your own brain in ways that are just really intriguing to think about.
Yeah.
I mean, I feel like this is part of the reason why that research like the main media picked it up, and it became like an event for a while.
Yeah, I think that's right. It helps us get some understanding. I think one of the other things about it that I find really interesting, of course, we're working in rats.
Yeah.
So we don't know what they're conscious of. And we don't know which of these things they're conscious of versus which are purely offline. And in humans, we probably have a better ability to take stuff that might be offline and have that enter consciousness in some way or another.
Than a rat does.
Right. And so maybe it's a little bit squishier in humans. And indeed, there's been a huge amount of work after this point looking at these kind of what are called ripples, which are these high-frequency oscillations that mark the time of these replay events in humans, and finding that they really do correspond to periods of memory retrieval, both in kind of online and more offline states. So I think that's right in some sense, that this is probably what's going on. This is probably the marker of that kind of spontaneous retrieval, oh, my mind wandered and I thought about this kind of thing, which clearly can be potentially really useful, right? It lets us think about stuff. It lets us store memories by sort of replaying them. It has a lot of potential functions.
Yeah. I want to ask this other question. The suggestion is that our brains will do these replay events to help consolidate memories that are more important. So if I go to a busy intersection, I almost get hit by a car, we want to consolidate that memory because next time I need to be very careful. If I have cereal for breakfast, that's not important. That happens a lot, etc.
Yeah.
But that suggests that our brain has some sort of intelligence and is making these decisions, and it has to be tied to some biological marker, probably.
Yeah, absolutely.
We don't know, or we do.
So this is a lot of our earlier work was actually trying to understand how any of that works.
Yeah.
So what we found is that new experiences, and again, other people had found data like the McNaughton Lab and others that were consistent with this. New experiences greatly increase the preponderance or the prevalence of these replay events, and also rewarded experiences. So we had a sense that it might even be particularly surprising rewarded experiences lead to an increase. So the suggestion is that when experiences come in, they're tagged somehow based on that importance. And, we don't still quite know the mechanisms of that. But, for example, neuromodulators like dopamine almost certainly play a role.
Right,
that if you get an unexpected reward, you maybe get a blast of this thing, it happens, and that says, okay, whatever just happened, turn it up. Right? So this becomes a knob, and then you can imagine different things occurring over different time frames might have different knobs that can sort of modulate this process.
Yeah. Are you looking at that still, trying to figure that out, or is somebody?
Yeah, I think definitely. So we're not studying the. Well, let me rephrase that. We're studying everything. So this kind of work, I was just trying to say in my lab, but we're actually doing a wonderful collaboration with my colleague Josh Burke, and also who's at UCSF, and also Nathaniel Daw at Princeton, to look at how reward and dopamine in particular are related to these kind of replay events. So trying to ask exactly that question, does reward enhance replay? Does replay help distribute reward around the world? All of those sorts of things.
Yeah.
So we're trying to figure that out. But I was thinking right now that work is going on. The dopamine part is going on in Josh's lab. So, but we're part of this group trying to figure this out.
Okay. I want to go back to this how we started talking about media in the beginning. So I think this was like 2010. There's a radio show in New York called The Brian Lehrer Show. Maybe you don't remember this, but it's a call-in radio show back when that was kind of more a thing when people listen to radio, and they pick a thing from the news, or maybe there's like new legislation in New York City or the state, and then they talk about it and they have people call in and give their thoughts on it.
Yep.
And so they had you on very briefly.
Yeah,
and it was to talk about the replay events, and basically what we just talked about, that when the mind is at rest, it may replay something that had just happened, and that's the way memories are consolidated. And they had you on and they said, hey, Professor, we understand your work shows that you really need to take a break. You have to take a break in order for your brain to be healthy. And you said, well, that's not quite what we've shown. We've shown something else. And they said, okay, anyway. callers call in, and they said, callers, how do you take a break? How do you stay unplugged?
Yeah.
Because that was the show that they had lined up for the day, right? In fact, there was a neuroscientist who called in specifically to say, this isn't the way the brain works. But now after hearing you clarify, he's like, I get it. He's saying something different. And then they just went on with how you need to unplug your brain. And the New York Times did like a very similar thing. Where they're like, BlackBerries, because BlackBerry was the phone of choice back then. BlackBerries are ruining us. Our brain never gets a chance to rest. It's really important. Loren Frank's work here tells you need to. None of those things are really the work that you're doing, right? And I'm wondering if that's frustrating to do a really beautiful experiment, put together a paper that's articulate and careful. It's gone through peer review, and it's not really, the message doesn't get clear.
Yeah, it's clearly frustrating. It was also a real educational experience for me, right? So I wasn't as careful I tried my best to be careful in those online settings.
Definitely did on that radio show.
Yeah. So I was doing my best, but I had learned after some interviews beforehand, I think I'd done some interviews before that where I had been a little bit, it could be this.
Yeah.
And the could be got taken into it is this.
And you're trying to be like amiable in the interview.
Yeah. And so I think there was a learning experience. It is frustrating. And at the same time, I feel like any public engagement with science is such a good thing that I have very mixed feelings about it, right?
Yeah.
So like, I really appreciate that people are willing to pick this stuff up. It is challenging though when you get to this, this is the new cure for X, or this is the new thing, and people don't understand the uncertainty.
Yeah.
And that our world doesn't seem to be good at maintaining the sense of what do we really know and what do we not really know. And I see that as a massive problem right now everywhere. So this is just one example of it.
Yeah, even going back to like the Holocaust stuff. Like
Absolutely.
There are things that are knowable.
Yes.
It's just difficult to convince people that things are knowable.
Exactly. And people believe what they want to believe and maybe are not engaged as much in the process of questioning their own thoughts, right? And I think that's the wonderful thing about really good training in science, right? Is it says, look, I have to figure out how I could be wrong. And I have to push that as hard as I possibly can, at least as hard as I can reasonably do so that I'm not wrong. Or if I'm wrong, it's not because of something I overlooked, it's because of some mistake that I didn't understand.
Yeah,
right?
And if you are wrong and someone else figures it out, great.
Fantastic. Yeah, actually, I tell my students that being wrong in a clear way about a prediction before we publish it, not after, is the most insightful thing that happens in science, right? Because then you know that framework that you've been using is not the right one.
Yeah.
And that's clear data, where positive data is never as clear.
Yeah. I have one thing I want to ask you, one last thing. You said earlier that you realized that you were not going to be the world's best astrophysicist. You went on to do something else. I'm not saying that you're the world's best neuroscientist,
Certainly
but have you realized that might be where you should have been all along?
It is. Yeah, no, clearly this is an incredibly good fit for me, right? It ties into me being pretty good or quite good at a whole bunch of things, and being able and knowing enough of the language of mathematics and statistics and engineering to be able to work well with other folks who are real experts in those fields. And I think that's been a lot of our strength, is sort of leveraging those kinds of collaborations. I guess the other thing I've kind of realized is that this, neuroscience is becoming an increasingly social collaborative thing. The lone investigator working with their students or postdocs in the lab is less and less moving the needle. So then it becomes, okay, not only do you have to do that, but you have to know how to interact with people. You have to know how to make sure that everyone is taken care of in these collaborations, right? So that people are not falling by the wayside. And that's a whole other set of things that we're typically not taught very well, or, may rely on a completely different set of skills.
Yeah. But that early physics really helped you.
Yeah, it's certainly a quantitative orientation and just having the math.
Yeah, the math.
Right? The math, right? This is what I tell students who are interested in my laboratory. If you really want to do this kind of work, don't worry about the biology. Go take the math and learn to program. Because the biology you can pick up, math is cumulative in a way that biology is much less so.
Yeah. Perfect. Thank you. Thank you very much.
Sure.
All right, that's it. I'd like to thank Loren for being on Synaptic and for having me into his home. I hope he enjoyed his public engagement with science as much as I did. When I left, I got a ride back down off the hill, and as we worked our way toward the little town of San Anselmo, I thought, this is the bike commute that Loren does every day. It's a pretty nice way to get to work. Okay, this episode will be archived on thetransmitter.org, where we also have a transcript, and this show can be found wherever you get your podcasts: Apple, Spotify, YouTube, or on whatever podcast app you use. Some of the information for the intro was sourced from the article Julius Caesar Aranches and the Hippocampus of the Human Brain: History Behind the Discovery, published in the Journal of Neurosurgery in 2015. If you'd like to comment on this show or whatever we do at The Transmitter, you can find us on the social media platform X, you know what I'm talking about, where our handle is @_The Transmitter. We're also on Blue Sky and Mastodon. Our theme song was written and performed by Chris Collinwood. The next episode will be out May 1st. Thank you for listening to Synaptic. Until next time.
Gives her enough attention.
She's really cute, actually.
She's a really good dog. She's yeah. Are you a good dog? Yes, you are.